was almost perfect.
Sit down.
That was almost perfect.
See, I would be scared. That was life-threatening.
You are embarrassing me so much right now. Like, I feel like I'm that teacher on TV that has zero control.
Yeah, pretty much.
He's like super nanny, but for I love watching this video on TikTok.
Give me, I know. Number 12. They're so bad. I'm so sorry. Yes, give me the question. Yes, thank you. All right, we're on number 12. Follow along. Bryson?
Airplane redirect.
You're picking me off today. All right, can I use synthetic?
Yeah.
Why? Why? Finley, tell us why. So what? No coefficient in front of x. No exponent on x, and it's just plus or minus a number. What goes outside of the upside down house? -9. I got to change the sign. Give me the coefficients that go inside. 190. Why do I need the 0? Placeholder for which place? All right. First step is what? Drop it. Then do what? Multiply. Add. What'd you say, Grayson? All right. Shh, Dibbling.
What?
Grayson said we did this one yesterday.
No, we did not. Oh, well, I didn't do it. Then can we do 14?
All right, let me finish interpreting this if you didn't get it yesterday. Will interpret the answer. X to the third. There you go. Perfect. That's the answer. Why? So remainder constant x. It is. Yes, exactly right. That's a great observation. It's always one less than what you start with because you're always dividing by x to the first power. So you're taking it down 1 degree. All right. Somebody said, could I work on a 14? And you might have done different ones. Remember, you got to scratch out any 10 of them, right? Right. Say right, because that was right. Grayson Remp. Take your booty to your seat. Or your corner. Grayson, this is your time to shine. What goes outside? 7. What are the coefficients inside? Drop it. Multiply. Add. Multiply. Multiply. Wait. Interpret your answer. Ready.
X3, 6x2, 6x, 10, -8 over n minus 7.
Minus.
You put in X.
Oh, I did. That's because I was writing in and he kept saying egg.
Okay, so that's what.
Either way, it's fine though. Either way, it's fine.
Hey, who in this class can do a better?
All right.
Nobody.
Prove it on your quiz.
I didn't look at I don't know that you. I need to sit next to Jason.
Let's review. Waterfall.
I need it. Miss McGee.
Whoa, why are y'all acting this way today? All right, listen. Do you give me a thumbs? Do you need me to do? Are you okay on synthetic? Are you sure? Do y'all need me to do a long division? Give me a thumbs. Give me a thumbs. Give me a thumbs. Okay. Yes. So listen, how about we do one of the synthetic, but we do it long division, so you can see that we got the right answer. How about that? So give me one. 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 Anybody? Somebody? Anybody? Why don't we do one of the ones we already did? Let's do this one. What do you mean? Oh, okay. Well, somebody pull out your long division sheet and give me a problem. 2x squared plus 9. Oh, Bella. You were so confident. Okay, Lakin's got it. Give me one, Lakin. Long division. Is this outside or top of the fraction? Top. Okay. 7x.
The one on the top was.
Why? Oh.
5x to the third. Oh, 6x to the third. It'll be 4. Wait, what in the world?
Making it even so I can do this a little easier. Because Bella wanted one
It
without
would be
4.
6x to the third.
No, it wouldn't.
No, you have to divide it, not.
Okay, wait. What do I multiply this by to get this? 4x to the third. So go to the third column. 4x to the third. Yes? Multiply around. Please let this work. This is probably going to be really crazy numbers because we just kind of took one. Why are you confused? No, Finley. Put that away. Put that away before he gets to you.
Where do we get the next 4x?
So it'd be 14x to the third.
Grayson. Okay, listen. Everybody listen because I don't want y'all confused on your quiz. Negative 10x to the third, right? The first one's canceled. I'm subtracting all of this. The first one's canceled. Negative 10x to the third minus negative 4x to the third. So it's negative 6x to the third, right? And bring down your 8x squared. Now everything all over again, right? Yep, wait. No. That came from multiplying to this one also, because you have to multiply to both. All right. What do I multiply 2x by to get negative 6x to the third? Negative 3x squared. Multiply around, right? Boys, if I see any more paper airplanes, it's fixing to get serious. Negative 6x to the third. Now times it by negative 1 plus 3x squared, right? And I'm subtracting all of this. 8. I did what? Did I do it bad? Oh, I did do it bad then. No, y'all don't understand what he's saying. But what can you multiply 2x by to get, you'd have to get a fraction. Yeah, I'm not going to give you one that we have to do a fraction.
I don't understand.
Throw that in my room. I am going to respond to your daddy's email, and I'm going to tell him. Okay. I really got to tell everybody. Okay. Could I do this one with synthetic division? Why? Why? There's a 2 in front of the x, so that's a no. So I'm going to do 2x minus 1 into 4x cubed plus 6x squared minus 10x plus 4. This one's going to come out nice because it came off the paper. What do I multiply 2x by to get 4x to the third? 2x squared. It goes in the squared column. Multiply around. 4x cubed minus 2x squared. I'm subtracting all of this, so I'm canceling 8x squared, that's right, and bring down the minus 10x. And now my whole process starts all over again. 4x, positive 4x, yes? Multiply around. What's 4x times 2x? 8x squared. What's 4x times negative 1? Negative 4x. Again, subtracting all of this. Negative 6x. Drop it. And again, 2x times what gives me negative 6x? Negative 3. Multiply. Not yet. How do you know when to stop? That's been the question. Let me finish. That okay, so whenever I get to this point, right, I end up with 1, right? That's the remainder. How do I know that that's the remainder? What can I multiply 2x by to get 1? Nothing. That tells me it's a remainder. That's not necessarily always going to work. But there's nothing else.
Just a matter of 3.
So you don't necessarily have to in long division. You can figure it out without it. I would be in the habit of always using placeholders for both. So the remainder is 1. So there's my answer. Yeah. Here we go. All right. Y'all got me on my soapbox. You found my, what do you call it, your Achilles heel? Don't let them laugh at you. Well, for the longest time, you know the word FAUX? A faux something? I thought it was fox. I read it as fox all the time, and I was a whole grown adult teaching school, and I said something about a fox jacket. And they're like, a fox jacket, like a coat, like a faux leather, or a faux like fur jacket. Okay, right. That's what I said. The other word I could never pronounce was duvet. I always thought it was a dovet. Yeah, dovet. Dovet. All right, here we go, boys. Factor and remainder theorems. What do you get? What's the remainder? The remainder is 0. If the remainder is 0, we touched on this yesterday, but ever so briefly. If the remainder is 0, tell me what I know about this number and this number. These are factors, right? These are factors if that remainder is 0, yes? Do you agree then, if I tell you that something is a factor, like let's say I said 10 is a factor of 70. True or false? True. How do you know? 70 divided by 10 goes in evenly with no remainder, right? Could you easily find the other factor? What's the other factor? 7. How did you find that? No, I'm complicating this so that you understand it when I apply it to polynomials. Okay, so if this is a factor, I divide by it, then what I also get is a factor. Huh? Now, not bad. I already made some. I brought all my mess ups today. Next time I bring mess ups, I'll save them for y'all.
What are they called or what?
All right. Could you also tell me this? What does it mean when you factor something? Breaking it down and multiplying the factors together, right? So would you agree that if I wrote 70 as 7 times 10, that this is factored form? In other words, I divide, and what I get when I divide, I could put those two things together, right? Okay, so I'm going to apply these same thought concepts to polynomials. Let me pass these sheets around because we'll just work off of here. Nothing. No, nothing. Zero. All right. Here we go again. It's easier for me to explain this with an example. You will notice one thing about these. They are almost always, in fact, guys, 99.9% of the time, these can be done synthetically. Now, here's what it tells me. X plus 2 is a factor of the polynomial. So tell me what you know that means right off the bat without doing anything. If it's a factor, what does that mean? Remainder of 0 when I divide, right? Now, my goal here is to completely factor this polynomial. But if I go back and think about all the tools that I've learned to factor polynomials, right? It's not quadratic form. It's not a special pattern. I can't slash it. There's nothing I can do with this, right? So I have to have kind of a springboard to find the other factors. So here's what I'm going to do. I'm going to give you some little steps here. How to factor given a factor. Step 1. Divide by the factor. Again, all of these are set up to do synthetic. got it, which makes it a whole lot easier and is a whole lot quicker. Okay? So looking at this one, if I'm asked to factor this completely and I've got a factor to start with, here's what I'm going to do. I'm going to divide by that factor. Yeah. Well, what goes outside? -2. Don't forget placeholders, right? All right, 5, 4, 3, 2, 1, and a constant, so I don't need any placeholders. And I'm going to go ahead and fill in 1, 2, -9, -18, 8, and 16. And let's just divide this very quickly. We'll drop it. Multiply, add. Here we're back in our 80s workout. Multiply and add. And multiply and add. And multiply and add. And multiply and add. Now, okay, I know I've done it correctly because if that truly is a factor, I should get a remainder of 0. Did I get a remainder of 0? Yes. I 100% did. So I know I've started out correctly. All right, y'all with me? Grayson, you with me? If you get a remainder, then you've done something wrong for these, okay? All right. Now, how we know what? You just have to. Grayson, sit your tail down and stop. He's not doing your delta math for you. No, go sit down. Go sit down. All right, look. All right, write it. Write it as a multiplication. Here's what I'm going to do. Write it as a multiplication problem. In other words, remember how if we said 6 divided by 3 equals 2? Then we could say 3 times 2 is 6. We're going to do the same thing here. We divided by x plus 2, yes? And what's left when we divided by x plus 2? But give it to me as a polynomial. X to the 4th Now, my original direction is to do what? Factor completely. So here's what I'm going to do. My very last step is factor what I can. Can I factor this piece any further? Nope, it is a linear binomial. I cannot, unless I can take out a GCF, I can't factor it any further. So I write that. But look at the next one. Can I factor that? Yes. It's not a quadratic, but it's quadratic form. Just form. Which means I can do it like normal. I can multiply the ends and I can slash it, right? So what multiplies to 8x to the 4th, but adds to negative 9x squared? Negative 8 and negative 1, right? Negative 8 and negative 1 squared, x squared. Tracking with me? Exponents are just a little bit different, but that's okay. All right. Slash. No, this x plus 2 is just following me right on down. What can you take out of the first two? What's left? What can you take out of the last two? What's left? So I've got x plus 2, x squared minus 8 times what? What's left? Is it factored completely? No, I can still do something else.
No.
Ah, perfect squares, right. Difference of two squares. That's right. Why can't the other one be done, Will? 8's not a perfect square, that's right. So I've got x plus 2. X squared minus 8, can't do anything with that. But the x squared minus 1, isn't this glorious? Look how we are taking everything we have learned and pouring it into one problem.
This is too much. This is too time consuming to do. You know what? I'll get on these problems.
Let's do one more together. All right. Stay with me, stay with me. All right, y'all stay with me. Look at number Look at number 2. Sorry. So our stuff. Factor f of x completely. So the first thing I do is what? Say that again. Yes, you absolutely do. You absolutely do. That's a good point. All right. So the first thing I'm going to do is divide, right? Jason asked a good question. It's missing something, a constant. Do I need a placeholder? Yes. Even though it doesn't come in the middle, it's still on the end. You still have to have everything from highest exponent all the way down to the constant. Okay. So I've got 1, 5, 8, 40, 15, 75, and 0. They're just this way so you can factor. They won't always do that, but how can I know that I did this correctly? I have a 0 at the end, right? Do you always get a 0 at the end when you do synthetic division? If it's a factor, but not every time you do synthetic division. Students always want to go, wait, I got a remainder. You can get a remainder with synthetic division, just not if you're dividing by a factor, okay? All right, write it as a multiplication problem. X plus 5, I'm listening. This is called the remainder theorem. All right, and your instructions said to factor completely. That first parentheses, that binomial, I can't factor that any further, right? So now I move to that second parenthesis. Can I factor it the way it says? X. What am I going to do about an X? Take it out, right? It's a GCF. Take it out. Put it out front. It doesn't matter if you put it in between or out front. I like to put it out front. And what's left is x to the 4th plus 8x squared plus 15. I got quadratic form again, right? What multiplies to 15x to the 4th, but adds to 8x squared? Emily says 5 and 3, and he would be absolutely right. Dang. I know, I'm sorry. We're going to slash it. So I got x times x plus 5. Take out an x squared. Leaves me with x squared plus 5. Oops. What can I take out of the last two? 3. What's it leave me with? All right. Whoa. X plus 5. What's my factor from here? This is this. This is this. So all of this, I'm just continuing on factoring all of this. X squared plus 5 and x squared plus 3. Is it? Yeah. Is it factored completely? There's not, it's, yes, it's factored completely, so I stop. Okay. It's everything we have done, yeah.